We'll be back to the next video on deviation by a plane mirror. We had considered a ray of light, AO incident on a mirror, M at point O as shown, and we had come up with the drawing for our consideration. We have looked at angle of glancing, incident, reflection, and the angle of deviation. So, what is very true from here? If we look from our diagram here, it is very true that angle AOM, if I can call maybe this point here M prime, and this one can be SC, okay? Angle AON, that is angle G, that I'm meaning is equaling to angle, it is equaling to angle M1 or S. Is that okay? Why am I saying that is equal? That this angle is equaling to this angle because they are opposite angles. Are we together? Like we have something like this. Huh? This angle is opposite to the other. This is G, so it will be equal to this angle here that we don't know the value. Maybe you could call it maybe alpha, theta, anything. These two angles are equal because they are opposite angles. Are we together? So that means that after giving the reason why they are equal, we can now say that that means that angle M prime or S is equaling to also G. Is that okay? This angle is equaling to G. Is that okay? Good. And then we are aware that the angle D, the total angle of deviation is this angle here. Is this angle here. That is the angle of deviation. Is the same as this angle, which is the angle, it is the same as this angle here, which is the same as angle M prime or S. I'm meaning it is this angle here, which is just this, plus this angle, plus angle, which angle? M prime or B. Is that okay? That this angle D that we are seeing, it is the same as adding this plus adding that. You will get the whole of that angle. And that is the same as this angle plus that angle. Is that okay? Is that okay? Let me hope we are still together. And then, after writing that expression, what is angle O, angle MOP? We can say that here, but the angle M prime or B, is that okay? This angle here is the same as 90 degrees minus R. Is that okay? We know that this angle here is 90. This is 90. Isn't it? If this is 90, from here up to here is 90, and this is R, isn't this one 90? Subtract away R. Is it not true? So it is very true that this angle here is 90 minus R. Is that okay? Because the total is 90, this is R. That means that this one is the total. Subtract away the other one will remain for this one, which is 90 degrees minus R. Is that okay? And also, it is very true that angle I is equal to angle R. Is that okay? Why? This angle is equal to that. Why are we saying that? That is from laws of reflection. Is that okay? It is the law of reflection that is telling us that the angle of incidence is equal to the angle of reflection. Is that okay? Now, after accepting or agreeing that this angle is equal to that one, is it not true that I can now say angle M prime OB is equal to this angle is the same as 90 degrees minus I? Since R is equal to I, so that means that instead of saying 90 minus R, I can as well also say it is 90 minus I. Is that okay? Let me hope we are together. After looking at this 90 minus I, and then let's also look at the angle. After looking at this is also 90 minus I. Don't we know that also it is very true that angle AOM, angle AOM, this angle here, this one, this angle here, is also 90 degrees minus I, and it is also equal to G. Check on it, that this angle here, if this is, remember, this is 90, the whole of this is 90. From this to this is 90. Now, if this is I alone, this upper one is I alone, don't you think the lower one is 90 minus I, and which is the G? I think that should be very true, that this angle AOM is 90 minus I, because the total is 90, but already this is taking I, that means the lower one should take 90 minus I. But again, if it is equivalent to 90 minus I, it is also equivalent to angle G. Is that okay? So that means that it is very true that angle MOB is also equal to G. Because it is, if angle MI, if angle M complement OB is 90 minus I, and also angle AOM is equal to 90 minus I, don't you think this equal to this and this equal to G? Try looking at it. If that is very true, we shall now come back and say, my D, coming back here is angle MI, angle M complement OS, which is G, plus angle MIOP, which is also G here we have seen, and then finally we can say that D equaling to twice G. Is that okay? And from here, we can draw a conclusion that if light rays is reflected from a surface, if it is reflected from a given surface, the angle of deviation is twice the angle of reflection. Is that okay? How did we start that? One more time. We started by looking at our diagram as shown. We drew our mirror represented by M prime to represent the mirror, and then we considered a ray coming from this direction as the AO incident at that point there, and then when it is incident here, it is reflected as a OB with normal at the same point. Is that okay? Are we together? And then we said that if that is very true, we said at the beginning that if the ray is incident on a given surface, the angle between that incident ray and the normal is the angle of incidence. Is that okay? Angle of incidence. And then when it is reflected, the angle between the reflected and the normal is the angle of what? The angle of reflection. Is that okay? And we denoted it as R. And And then we went ahead and also said that the angle between the incident and the reflecting surface is called the angle of glancing or glancing angle. Is that okay? And then we also went and said that there is an angle called the angle of what? There is an angle called the angle of deviation. Is that okay? Angle called the angle of deviation, which is the angle between the initial direction and the final direction. That when light was coming here, it was supposed to move in this direction. Is that okay? That is if it was not going to be reflected. It was supposed to move in this direction, but because it found this surface here, it got reflected. So the direction it was having and what it finally went, the angle in between is denoted by letter D and is called the angle of reflection. Beg your pardon, angle of deviation. Is that okay? It is called angle of deviation. And then we started after having that diagram, we said that from this diagram, angle AOM is equal to angle MIOS. What is angle AOM? AOM, the angle is this. Is that it? Is equaling to that this angle is equaling to angle MOS. Yeah? That this angle, this angle here, which is this, and it is G, is equaling to this angle here, which is this. Why? Which reason did we give? We said the reason is because they are opposite angles. It is opposite the other one. This one is here, another is opposite the other side, isn't it? So we said those two are equal. So that means that if this is G, this is also G, and we concluded that angle M prime OS, which is this, is also G. Is that okay? Good, if that is still okay. And then we proceeded by saying that how can we write the expression for the angle of deviation? How can we write the expression for the angle of deviation D? We said that to get this angle of deviation, to get the angle of deviation, which is from angle of deviation is this, which is the whole of this. How do we actually get that? We said that is the same as adding this angle plus this angle. And we said that is adding angle MOS, that is this, plus M prime OB. That is if you add the two, you'll be saying this plus that will get the whole of that angle. Is that okay? And then we say that, but we are aware that angle M prime OB is 90 minus R. Why? Because if you look at our diagram here, we have something like this. If this is our normal, this was R, and we said this is 90. Is that okay? So that means this one should be 90 minus R. Isn't it? Because the total should be 90. So if R has taken this, that means the remainder, say 90, subtract away R, will be for the lower angle. So we said that that angle is 90 minus R. Is that okay? Good, if that is okay. And then we also went ahead and said that, but what is also very true is that this angle is equal to that angle I is equal to angle R. Okay? Which reason did we give for angle I being equal to angle R? We said that is very true because it is the laws of reflection of light. And then we say that if we have agreed basing on that, and then we also moved and said that it is very true that M prime, O prime, B prime, which is 90 minus R, can be written as 90 minus I. Is that okay? it can be written as 90 minus I because R can be replaced by I because the two are equal. And then we said if we have agreed that is 90 minus I, and then we went on the left hand side. We went on the left hand side and looked at something like that. If I have that, we looked here that if this is representing by incident ray AO and this is normal, we said this angle is angle I. And remember, this is 90. If this is 90, it means the lower angle is 90 minus I. Is that okay? Because the total is 90, and if the upper one is I, that means the lower one will be the total subtracted with the other one and remain with an angle of the lower one, that is 90 minus I. Is that okay? But again, we said at the same time on our drawing, however much this angle is 90 minus I, it is also G. Is that okay? It is also angle G. So that means that if this angle is 90 minus I, it is also the same as angle of glancing, isn't it? In other words, angle of glancing is the 90 minus I. Is that okay? And then we say that if now this is 90 minus I, that means that angle MIOB is also G. Because 90 minus I is G. But if AOM is this and is G, and also M prime OB is also 90 minus I, don't you think it is also G? Therefore, that is why we are saying that, because 90 minus I is the same as G. Is that okay? Good. And then we said if now MOI is G, that means that this angle here, we can also call it angle G. And then we come back to our equation here. We can now say that if we are subtracting angle MIOS, M prime OS was already G, so it means it's G plus angle M prime OP is also G. That means D equal to D plus G, and then D will equal to twice G. Is that okay? And from this statement, we can conclude that if light rays is incident on a surface, the deviation produced, conclusion that we shall use ahead there. Which conclusion can we make from there? We can draw a conclusion that if light ray is incident on a surface, the deviation produced is equal to twice the angle of glass. So that is what we shall always be using, that if we have any scenario where light rays is incident on any plane surface like a plane mirror, the deviation or the angle of deviation, the change in direction, the angular change in direction will always be twice the angle of glancing, where the angle of glancing is the angle between the incident ray and the reflecting surface. That will help us in the next video, where we are planning to derive the deviation produced as a result of two mirrors inclined at an angle, say theta. That if we incline two angles at each other, what is the total deviation produced after a successive reflection on those two inclined mirrors. Let's meet on the next video for that part. Thank you.